Hello everyone, how are you? So once again we are back over here. So last time in the previous session and previous to previous session we have seen that like the two main topics. First is a tax representation, which is include the bag of words, TF idea, and the word embedding, right? And second session, so which is the previous session taken by the Dr. Nikunta Ilhamani. So they have covered everything regarding the language modeling, which is include the Ngram, RNN, LSTM, and GRE. So in today's session, we will able to see about the practical hands-on. So from now, I will showcase you the practical demonstration of these, and I will also showcase you the end-to-end libraries, which you are able to see on the screen that one notebook is open, and in this notebook, I have written a whole code, which you are which you are able to see on screen. So let me share the whole screen so you are excited. So here today's session regarding the text representation and the language modeling hands-on. So on screen you are able to see that like we have covered the basically the two topic text representation and another one which is known as a language modeling. So let me first tell you about the tax representation. So in tax representation, we have seen that like how bag of word is working, what is TF, IDF, and word embedding. So if you don't know about that, don't worry. I will also explain it over here. It's like what exactly this is all about. So imagine one scenario where you are walking into the Immerse library, which is filled with a endless collection of the stories, poems, and the articles. So now picture the machine trying to make a sense of this vast sea of the words, right? So how do they understand the meaning behind the words we use? So this is where the text representation comes into the play. It is like translating the language of the words into the form, into the form, basically. So it is like translating the language words into the form that computer can easily grabs and analyze. So today we are setting off an adventure to explore these three essential methods that represent the text. So first method you are see on the screen is like the bag of words. Bag of words, right? You can see that basically we embark the journey of three basic methods, which is the most powerful methods in the text representation. So first is a bag of words, second is a TF-IDF, and third one is a word embedding. So each method have their own perspective. Like each method has their way of representing the text. Okay. So let's explore the first one, bag of word. So here you are able to see that like one bag, right? Bag of words. So bag with a one of word, right? So think on the bag of word as a simple and efficient way for like a machine to understand the text. Imagine each document as a bag filled with a word, right? And we don't care about the order or the structure of the word, just how many times each word appears. So it is like counting the frequency of the word in the document, which is creating the numeric pattern that represent its content, right? So here you can see that bag of word. So these, just imagine that this is our one document. So in document you are able to see that like there is a one doc which is a which contains the script is I love this movie. It is a sweet but with the satirical humors, and the dialogue is great and the adventure scenes are fun. So it is managed to be visual. So this is blah blah blah. Something document is available. Then after just transforming that document into the bag of word, you can see that each word is separated, right? Each word is separated with the space. So this is known as a tokenized with the one bag. Okay, and then just after the splitting each word separate, we have prepared one bag, which is you are able to see on screen, right? And then after we can counting that, like okay, particular word, how many times it's repeating. So this kind of structure is showcasing that this is a bag of word, which is known as a most significant and a straightforward method to counting the word frequency. So here we are using the word frequency counter, right? So the word frequency counter showcasing that each text document is treated as a bag of word, where each word is counted and represent its own feature vector. So when I told a feature means it's one of the word, right, which is important word that used in the particular document. Okay, so which is showcasing that how many times this particular word is used inside this, right? And these vector essentially tell us that how often each word appear in the document. And some we are also managing some ignoring orders and grammatical structure as well. So when we are talking about the bag of word, you always think in the terms of we are just splitting that word separately, and then after we are counting that word, like how many times single word is coming, right? So there are some pros and cons. Right. So pros and cons is like this is easy to implement and computationally efficient. Right. And this is basically the second is like it's work well for the straightforward task, like we are sorting the document into particular categories. Right. So I will showcase these things into the example as well. And the cons is like it is ignore the word of orders, which is losing some information. And second is like it can be sensitive to the common but less meaningful words like the a, which is also known as a repeated word in the grammatical things, right? So which is we called it frequently appear but carry little meaning, right? So let's see the example. So on the screen you are able to see that we have used two libraries, right? First library is pandas. So this is basically known as a data pre-processing library. Right, Pandas is a very famous library to just play with the data. Panda is basically help you out to do the data analysis and manipulation tree, where you can use this library with the Python. Right, so with the Python means like you can utilize on a better way. So when you want to just play with the data like SQL, so you can do the data analytics. You can do there are a lot of tasks with this. You can do the like you can plot the graph. So I will showcase you the example of you can see that you also refer you can refer this book as well. Okay, so this is the first library. Second library is a scikit-learn. Scikit-learn is basically the very famous library where we are utilizing some functions from scikit-learn, right? So here we have a lot of functionality which I want to showcase you. So here you can see that we are using feature extraction method. So when we are just going to release on go on API, we are going on the feature extraction. You can see that it is over here, right? So over here you can see that feature extraction, and you can see that we have there are a lot of functions, right, for the feature extraction. So this is a dictionary vectorization, feature vectorization, right, which is these are the feature extractions. So like let's say you have some raw data, okay, and so feature extraction is considered as one module which is help us to deal with the like the raw data. It is which is a help us to extract the feature from the text, from the images, from the unstructured raw format of the data, right? So today we are using these two library. So and we are also using one function which is known as a count vectorization. So this count vectorization is basically known as a function, but how it works, so I will showcase you that. Here you are able to see the image, right? So here we are providing the sentence like this. This is a good, this is bad, this is awesome. So basically when we are using this class count vectorizer, this vectorizer will help us to just splitting this word like this. And uh, it is also splitting this word and calculate the unique word. So let's say this is a unique, this is repeating 3 times. Okay. So these become one unique word. Ease is also become one unique word. Good is also become one unique word. Bad is also become one unique word. And it is also giving the index to these all the words, right? So it is convert the unique word into the index, and then after this index become the column name. Okay, and then after what we are doing is we are able to see that here these is a good, right? So what counter vectorize doing is count vectorize just repeatingly do the 1 0 1 0. So where the word is available, it is putting the value 1, and if where word is not available, it is putting the value 0. So let's take a first sentence. These is a good. Okay, so here we have seen that these is a 1, right? This is repeating. So here you are able to see these is and good. Then after nothing is there, right? So bad and awesome is 0 0. Then after second sentence, these is a bad. So inside this column we are putting a 1. Is that is available, so we are putting a 1 over here. And good, obviously good is not available in this sentence, so it is taking a 0. Bad is available word, we are taking a 1. then after awesome, then after nothing, so we are putting 0. Same way this is awesome, so this is also create a something like this. So I will showcase you this example. So same way I had just imported these two functions, two libraries. One is a pandas and second one is scalar. So you can also implement this library by just importing. Okay, so here first of all we have taken the samples. So sample is a sample document we have taken, which is known as a list of the sample documents. So here you can see that we have taken the 4 samples. This is the first document, this is a document, is the second document, and this is the third document, and is this the first document? So this is a first tab, right? Which is known as, instead of here you can also read your whole PDF file as well, which is considered as a one list of string, right? Same way even you can use a text document. So it is contained any document which is also come as a list format over here. So this first index is considered as a one list, one document. And so same way we have 4 documents. So here we can say that we have a 4 document, right? Now first step is to, as per the image you can see that first step is to, we have to calculate the unique word index, and then after it will give us a matrix like this. So what first step is to, we have to define the count vectorizer. So here you can see that we have defined the object. So in a Python programming there is a fundamental concept which is known as object oriented programming. So each object oriented programming contain some classes, right? So here we have a pre-built classes, right? We have imported from the scikit-learn library. Right. So when we are just importing this count vectorizer, we have to create an object for that, right? So here we have created count vectorizer class. Okay, so we are calling over here to just define the object of it, right? So here we called it, we have created the object for the count vectorizer, which will help us to calculate the count or create the word, bag of word representation, right? So this is the first step. Now we have a document, right? Contain the 4 index. This is the first document, this is the second document, this is the third document, and over here. Okay, and then after vectorizer, create the vectorizer is basically, you are able to see that like a second step we are taking. So second step is like fit and transform the document into the bag of word representation. So what we are doing is like we have a count vectorizer, right? So this count vectorizer is now taking this document as an input. Okay, so what we are doing is we are just fitting this document over here, but where it is fitting, so here we have taken the object, right? Object is a vectorizer, so we are using that, and these object have one method which is known as a fit transform. So this fit transform method directly convert this document into the bag of representation within a one line of code. Okay, so what you have to do, you have to just pass this document into the list format. Okay, so this is our list format. We have to pass it and it will convert bag of word format. Okay, so here you can see that once we will pass, it will showcase and convert into the this format. I will also showcase how it will look like. Okay, and then after this it is converting into the array format. Okay, and then what we are doing is we are also giving this index, right? You can see that we have, once we have given this index, we'll give this index into the column name. So that's why we have passes this over here, vectorizer dot get feature name out, and then after it will create a whole table like this, okay, and then after we can also see the list, like how many columns are become the list of that, and then after we are creating and displaying the bag of word table, and same time after calculating this bag of word format table, we are calculating the list of that. So let me showcase, run it anyway. You can see, right? This is a unique word, and document first is second, the third, and these. So these are basically the list which we have seen over here, right? 1010 something like that. You are able to see, right? So let's say document word count 2 times. So we are writing the 2, something like that. Okay, so we have a four sentence, 0, 1, 2, 0, 1, 2, 3, right? And then after, what we have done is we have calculate each word count. So let's say end is come for one time. So here we are using one function that is known as df dot sum. Axis is equal to 0. Axis is equal to 0 means like this is counting a table with each word. Okay, so the table with the count of each word in the document is a display over here. You can see that and is repeating one time, document word is repeating four times in four sentences. First is repeating two times in four sentences, is repeating four times in two sentences, one is repeating one time in sentences, four sentences, second is repeating one time in four sentences. So this way, this is repeatingly printing, right? And you can even access these notebook. Just go on github.com Ashish Patel 26 and LLM engineering crash course. Once you open these, you have to go over here, the tax representation bag of words. Just click over here and you are able to access this notebook. Okay, and you will see like this, and then after you have to connect your notebook. You will get the one button, connect button over here. So you have to click there and you will feel that like your notebook is connected and you will see the display like this. Okay, so yeah, this is a bag of words. Second one is a TF-IDF, right? So TF-IDF is basically the term frequency, inverse term frequency, which is a full form of TF-IDF. So TF-IDF is basically built upon the bag of words. So inside the bag of words, we have see that we are not care about the orders. We are only care about the how many words appeared and what is the count of that. Okay, so TF-IDF build upon the bag of words by adding the layer of importance. So it is a consider not only how often word appear in the document, but also how common it is across the entire corpus. Right. So let me take one example. Okay. Are you able to see that? Okay. So let me tell you basically the TF idea is built on the bag of word ideas, but add one layer that is known as the importance layer. It is not only count often the word appear in the document, which is known as a term frequency, but also consider how unique word is across all the documents. Okay, how unique word is across all the documents. So this is way the word that are rare or unique to a document get more weights, right? While common word gets less attention. So you can see over here the one example, which is which is contain the two, like considers one text two as a two document. One is a basic Linux command for the data science. So let's say you have a two document, two PDFs. One PDF contain one sentence, which is a basic Linux command for the data science, and second one is essential DVC command for the data science, right? And then after, what we are doing is we are just trying to create one matrix. Okay, first of all, what we are doing is we are just splitting all the unique word like bag of word. So you can see that basic, command, data, DVC, essential for Linux and science. Okay, and then after we are calculating the weightage with the help of some statistical method. So let's say you are using a cosine similarity, you are using any distance matrix. Okay, so term frequency, inverse term frequency is working on that. So let me showcase you some example of it. Term frequency, inverse term frequency. Yeah. So this is something look like this. You are able to see, right? Okay, let me open a new window. Right, you are able to see that. So TF-IDF, you can see that frequency of the word within the document. So that we have already counted with the bag of words, but frequency of the word across all the documents, that is still not counted, right? So here we are focusing on the both way, term frequency and inverse term frequency both. right? And the distance, like importance of particular word, that we are counting basis on how many time particular word is repeating. Basis on that, we are giving that importance to that particular word. So behind that, there is a mathematics that you are able to see in the notebook. We are using the log, right? And we are also using the distance metric. So let's not going into that much into the mathematics, and just directly calculate it over here, uh, right? So when we are calculating that, let's say we have a first sentence, right? Text one, which is contain the basic Linux command for data science. So you can see that we have all the words, but here we have allocated weights. So weight is not more than one, right? So whatever you are able to see, let's say zero point 0.5, so that is a probability. Okay, so probability, or you can call it a weightage. Okay, so tax one basic. So basic word is considered over here, right? So you can see that its weightage is zero point 0.5. When you calculating with this formula, you will get this. Okay, so ultimately W X Y we are getting. So let's say here we are getting the word basic Linux command. So it is written the probability basic with basic. So obviously it's a high probability because it's available in this particular sentence. So zero point 0.5. Same way we are calculating for each word. You can see that DBC is not part of this first sentence. So its weightage is zero. Essential is also not a part of it. So its word is zero. Right. Same way you can see that basic is not part of this. Weightage is zero. And over here the Linux is not part of this. Its weight is zero. So this way we are calculating this bag term frequency, inward term frequency. So let's not go into the deep dive into, but let me tell you the two pros and two cons. So basically the pros is that, so it captures the relative importance of the word for the document, right? So relative importance means like how relevant the particular word for particular sentence, right? And second one is performance. Right, so it performs well in a task like finding the relevant information or analyzing sentiments. So when you want to do the sentiment analysis, a kind of task, you have to pass through this basic technique of text representation, right? And cons is basically, so there are not high impacting cons, but yeah, it is a more computationally intensive compared to the bag of words, and its quality of the result depend on the data set you used for the calculations, right? So let's go through the practical, what it tells us. So same way we are using again the feature extraction. Okay, so let me showcase you how many methods is available there. Okay, so here we are able to see that on text side. So let me go down. Okay, so when you go on a scikit-learn and just going on the feature vectorization for the tags, we have a uh, four type of the classes, which is known as basically the method. So you can see that we have already used count vectorizer, which will help us to count the word collection, how many time particular sentence, particular word is repeating. Here we are using a TF-IDF, right? TF-IDF vectorizer, which is help us to convert the collection of raw document into the matrix of term frequency, inverse term frequency. So here you do not need to care about the mathematics, but when you click over here, it is showcasing that what is the internal parameter is and which method they have used. Okay, you can explore this document by your own self, because this is a very dense things. You can learn by just applying the different methods. So they are using the internal parameter, right? So you can see the n-gram range, and these are the part of that language modeling as well. I will also showcase you that as well. Right, so here you can see that there are a number of parameters that we are passing with. So here right now we are using only the default parameter. Okay, even when you explore this document, they will also give you the example at the end of this document. You can see that at the end of the example, you can do practice for yourself. Let's say classification of the text document. So you have to use a TF-IDF inside that as well, clustering the text. So that time you can also use a TF-IDF there, right? Feature has a, you can use at that time even the TF-IDF as well, right? So basically this is a TF-IDF vectorizer we are using over here. So let me showcase you. So here you can see that first is we have to import the library, right? Which is known as an instance of TF-IDF vector class is created inside the, right? So here we have, first of all, same thing, we have to create the object for the particular vectorizer, which is known as TF-IDF vectorizer we have created. we are using the same way. We have to just feed this document. I'm not declaring this document again, okay? Because this is already declared. Okay, for document is already loaded into the memory, so I'm not loading it again. Okay, now what I am doing is I am passing this. So same way, previously we have used count vectorizer and we have feed same function, feed transform. So TF-IDF vectorizer also have the same function, which is known as feed transform. What it can do, it will also convert this document into the TF-IDF vector representation. So just you have to pass this document and it will convert the X TF-IDF vectorizer. And then after we have to convert into the array format, right? So it will look like this, you can see. So this is a mathematical format. This will look like this. Okay. So the TF-IDF representation display in the array format over here. But let's say you have to see like this. See like this. But when you have a lot of document and there are a lot of columns, this is very difficult to see, right? So I have created a visual representation of it. You can see that. Then after what I had done is I have converted that into the same matrix. You can see that I have converted that into the same tabular format. But for that, what I had done is I have so till that step is the same. Okay, this is step 3. Step is the same, right? Till that. And then what I had done is I had used this TF-IDF vectorizer. So there is a one function which is return us the feature name out, right? Which is give us the feature name index, right? So you can get that and you can pass into the column parameter, which is directly create the column name. And here the array, which is showcasing the these array value, right? Which is directly fit into the tabular format. So only you have to pass these two values. So you can see that in 3 line of the code, TF-IDF is done. Nothing else you have to do it, right? And then after, whenever you want to print this, you can use display function like this, okay? And it will display like this, right? So this is basically known as a TF-IDF, term frequency, inverse term frequency, right? And it is also giving the particular word the weightage. First is, so one is not there, but first word is there, second is there, third is not there, second and first is not there, right? So these way this is represent. But what if let's say you have to create in the plot format? Plot is something like, let's say you want to create the heat map plot, right? So you are able to see over here, right? We have created heat map plot, which is giving the weightage for the each word by sentence. So you can see that 0 is a one sentence which is contain document first is the and this, right? So you can see that which one is our first word, first document is this is the first document, right? Now you can see that it is giving the weightage to only those word which is contain the which is included as a part of the word, right? Which is will be a part of the word. So here you can see the document first, right? The and this. So these are the parts. Same way first, second, third. So this is known as a TF-IDF representation, text representation. So this way you can create. But for that we have used matplotlib library. So matplotlib library basically used for drawing the plots. Okay, so this is one of the famous library. You can see, right? And inside the gallery, when we are going into the gallery, it will showcasing the number of plots. You can see. Okay, you can learn by just doing the YouTube. There are a lot of courses available. Okay, how to do the plot. But I have given here the basic plot, which is showcasing that. So first of all, I define the figure size. So let's say this plot size is a 12 by 8. Okay, so this is a 12 by 8, which is represent the inside that plot. We are just drawing a figure. Second is like a SNS. So this is also the one library which is known as a Seaborn. So we can merge two library to just draw the heat map, right? So you can see that this is a heat map plot, right? So this will look like this heat map something. Inside that, let's say you want to print something, then it will look like this. But let's say you want to also print the probability, it is also look like this. Or let's say percentage, right? Right. So it looks like uh, looks good, and it will also showcase that particular word into the weightage. So that's why we have used that sns.heatmap where we have passed our matrix, right? And then after I had given this color map. Color map is like on which format it's on which color style it will look. So I use a cool one. There are other color map is there. You can also explore. Okay. Then annotation is equal to true. Annotation true means it will print these value inside this. That is known as an annotation. Right. Same way, these are the other parameter you can pass and you can just play with the these this plot. Okay. Then after I had given the title, plt.title, tfid everywhere. Then x label is a word, y label is a document, and plt.show. So this 5 line will help you out to print this plot. And you can see that in 5 line, it's print very well. Okay. So this is basically the visualization of TF-IDF. Now we have a third topic, right? Third topic is word embedding, right? So word embedding is the one of the, we can say that like word embedding takes a text representation to the next level, right? So instead of just counting the words, they aim to understand the relationship between them. Imagine the word as a point in a high dimensional space, right? You can see on the screen, right? So imagine the word point in a high dimensional space where similar words are closer together. Right, and these allow the machine to comprehend the synonyms, antonyms, or even the word analogy. Right. So, word embedding is basically that's why known as text representation fundamentals. So he on the screen you are able to see that like I had just mentioned the 2 line, which is like instead of simply counting the words, they aim to capture the semantic relationship. Semantic means you are giving the meaning to the word. So that's why I told, right? It will help us to just calculate the synonyms, antonyms, even the word analogy of that. Right. So let's say we have a cat. Right. So here let's say we have a high dimensional word. So high dimensional word means like there are multiple way we can understand this. Right. So let's say moving beyond the counting of the words. So word embedding are create advanced method of representation in computational context. Unlike let's say simple word counting approaches like word to vector, bag of words. Word embedding aim to capture the semantic relationship between the words. So when I'm telling you the high dimensional space, right? So imagine represent the each word point in a high dimension like this. Okay, let's say in 3D, or let's say we have multiple columns, right? So here we have a 7 columns. 1, 2, 3, 4, 5, 6, 7. Okay, so these one column is known as a one dimension. Okay, so that's why here we can say that we have a 7 dimensions, right? And in this space, word that share a similar meanings or the context that are positioned close to each other. So we have calculated that way, right? With the help of word embedding. So what we are doing is we are converting this 7 dimension vector into the converting into the vector. So here you can see that this is a one row is known as one vector. Okay, so these way. So we are converting into 2D space like this. Okay. So here what we are doing is basically we are trying to find the similarity, which is known as a proximity. Proximity signifies a similarity, right? So I can say that like a word with a similar meaning are closer together in this space. So for example, let's say we have a king, right? You can see that we have a king, which might closer to the queen or the throne, right? But farther from banana, right? Which is farther from banana, or let's say farther from the man, or farther from the woman, or it's farther from the dog, or it's farther from the cat, right? So we are calculating the two-word similarity, how two-word is similar, right? So this closeness signifies a semantic similarity, right? Which is allowing the machine to grasp the relationship between that. So next session is on that semantic similarity. On next Saturday, we'll calculate. We will use that how semantic similarity. We will create one application with the help of semantic similarity end to end. Okay, right. So here, when I say that like synonyms, antonyms, or analogy, so word embedding enables machine to understand not only the synonyms like a word similarity meanings, but also the antonyms, which is known as the opposite meaning, right? And they can perform the word analogy. Right. So basically, we can say that in simple manner that like we can find the relationship between two words. So let's say man and woman, dog and cat, kitten and dog, queen and king. This way, right? So this is ultimately just draw the representation like this. So you can see that this is a word. You are converting this word into these vector representations, and then after what you are doing is you are converting this 7D vector into the 2D space. Okay. Okay, but yeah, there are some elusive tasks that maybe obviously it is always there. So where this use word embedding, where this word embedding use. So the rich semantic relationship, whenever you are captured by the word embedding, make them valuable for various natural language processing applications, such as let's say machine translation, let's say sentiment analysis, let's say question answering system nowadays we are using in ChatGPT, right? Where understanding the word meaning with its context is important, right? But like interpretation is really challenged. So while powerful at interpreting the exact nature of high dimensional space can be challenging, right? So the quality of embedding heavily depend on the size and diversity of the training data. So training data is nothing but the document that we have asked. So let's see the practical things directly, not dive into the lot of things. Okay. So here we are using one Spacey library. Spacey, I told you right last time, which is also the natural language processing library. So for that, we have to import the whole library first. Right. So this whole library we have imported. That is the first is known as a Spacey, right, which is help us to just create the what to vector sentence, the task and everything. So here we have used pandas, which is help us to just play with the data frame and all. Matplotlib, which is help us to create the plot. SN is also the plotting library. And Spaces help us to calculate some NLP related tasks. So what task have we had done? I will tell you when we are just going through step by step. Okay. So here we can see that first of all we are loading the Spacey library. So when we are loading any Spacey library, so we have a pre-built this kind of the language model, right? Pre-built language, English language model, right? English language model is something you can say that like which is include the word embeddings, right? So here you can see that English core web, right? English core web, which is a include the word embeddings. So this is our pre-built word embedding language model. So we are loading it in the NLP object, right? Next step, we are defining the one sample sentence, right? Which is known as a word embedding, provides a dense vector representation of the word. So this is basically our document, which I showcased you previously. We have a in the list format, right? We have a multiple document, but here we have only the one document, which is stored into this like this variable. Now what we are doing is by taking these as a function, we are passing this sentence over there, right? So we are doing the tokenization and get over there. So what is the tokenize, right? So whenever you are just throwing into the Google tokenize, what is tokenize, right? And you can write an example. You can see that multiple things, right? So let me give this example. You can see that tokenize. So here we have a one sentence, right? We are moving to LA. This is the original sentence. So here when we are just splitting this sentence into the particular individual word, you can see that VR is one token, moving is second token, two is a third token, and LA is a fourth token, right? We have so initially we are splitting with a white space. Okay. Then after, let's say you want to split with the prefix. So obviously prefix we are removing from over here. Then let's say exceptions. So exception is VR. So we are removing these VR. Okay. And then suffix. So it's a postscript. Right. So we are removing this one. And then exceptions. Exception is like LA with exclamatory mark. So these way we are doing that. So here you can see that every single annotation or the word which is removed, symbols and annotations will be removed as a separate tokens, right? And each token is basically considered as a individual token, right? So basically the tokenization, so when we are talking about in this space, so tokenizer is inside the space is used as so it take the sentence and it is split the word, and then after it's obtain the word embedding for each token in the sentence, right? So what here we are doing is here we are splitting into the tokenizer. So when we print tokens, right, you can see that you will see like this. Guys, don't see other output. First, let's see the this one. Okay, so the tokenizer. Okay, let me just put this comment over here. Let me print it. Right, so when I print it, you can see that it will print the message word tokenizer. Right, right. So token is initially just define the object. But let's say once it will be done, I will just remove this. And when we are printing the word embedding, right, it will look like this. Just see. You can see that it will print in the matrix format, right? It is huge in size, so that's why it is known as a high dimension, right? So that's why showcase you 7D 8D, right? This is a showcasing the high dimension space over there. Then after, what we are doing is we are using this word embedding, right? So how you can extract this word embedding? We are using for loop. So how it will look like, you can use word token from token, in tokens. So these tokens is basically the list. Okay, so that's why you can take a single value from each, and then after you will print after doing the column and print token dot vector. Vector is nothing but it will showcasing the list of dimensions, right? So that's why it's looking like this, and so that's why we have printed, right? So you can see this line as this Python code, right? Simple Python code. Then after, what we are doing is we are converting this word embedding into the tabular format, and we are also giving the column name like this, and we can also display this df word embeddings. So it will directly showcase you how many dimension is there. You can see the 96 dimension we have. We had talked about only the 7 dimension, but here we have a 96 dimension. So here when I told a 96 dimension, that means we have a 96 different type of the unique words, right? And each 96 different type of the unique word is known as a one dimension. Each word is known as a one dimension. Now what we are doing is we are giving the index to them. Right, so here same way we are giving the index to them, and then after we are printing this table. So instead of, let me cover it over here, let me display so it will looks good. And then after I have printed this, and you can see how it look like. So you can see the table is printed, and then after this is known as a word embedding. This is printed into the 2D. Right, you can see that how much complex it is. Right, so this is basically we are converting into the 2D. But let's say whenever you are just going ahead, you want to print same things into the 2D, you have to convert into the low dimension space, right? Which I have already showcased you. You have to convert these. So first step is to create this, right? What to vector. So we have already used this and converted it. But now task is to dimensionality reduction for the words. So for that we are using one algorithm, right, of scikit-learn, that is known as a PCA. So what I can do is I will use scikit-learn decomposition, and there is an algorithm which is known as a PCA, which is convert this 96 dimension into the 2 dimension or whatever number of dimension we can prefer. So here we have taken the 2 dimension. Okay. So till now it is the same. Okay. Word embedding array till the same code we are using, and then after what we are doing is same way. Previously we have defined, right, count vectors and all. So here PCA is basically the one kind of the algorithm which is also known as a class. Inside that we have to pass the number of dimension that you want to convert from 96 dimension, right? So here we want to convert from 96 dimension to the 2 dimension. So for that we are using a PC algorithm. So this is a parameter, and we have defined the object for that, and that object have a same method that is known as a feed transform. Inside that you have to pass this array. Once you will pass, it will convert this word embedding into the 2D, right? 2D. So here 2, right, we are converting PCA into the 2. So PCA full name is a principal component analysis, right? So when you write PCA, it is showcasing the figure. You can see that it is convert any number of dimension image into any this image is not clear. Okay, let me showcase this one. This one looks good. Why it is not loading? Okay, take me to some other example. Oh my God, this one. You are able to see that, right? These 96 dimension convert into the this way into the 2 dimension. PC1 and PC2. PC full form is a principal component. So which is a principal means one of the main component, right? So it will calculate the PCA values, and inside that we are also calculating explained variance, which is showcasing that from 96 component which are component is most important, right, which is known as explained variance. Here we are not calculating, but I will showcase you in very brief, right? So here we have taken the PC1 and PC2, and we are passing that whole column over here, and we are trying to create one embedding, right? That data frame is nothing but the table. This is convert this 2D into the column format, and then after we are also creating one column. So this way even you can create. So let's say this is a table. Now we want to create one column over there, so that is a token column. So we are creating that, and same way we are passing the for loop, and now we want to display that, so it will look like this. This is a 2 column, principal 1, principal 2, right? And this way word embedding provide dense vector representation of the word, right? So this is a sentence, and I had this is a point that we have converted that whole sentence from 96 dimension to the 2 dimension. This way this will look like. Okay, there are other code I have done that, right? For the 4 sentence you can see that you can play with it directly, right? And these are the some references that if you want to explore. Okay, so this is a first session on the tax representation, which is done. Okay. Now, guys, if you have any questions or anything, you can ask regarding the tax representation. Else, we are going for the second session. That is for the language modeling. So this is very simple session. Okay, I will explain you the RLN and Ngram, and other code you can also understand by your own self, LSTM and GR, right? And if you like, if you want to contribute, you can come and join the community, and you can approach us. Is like, okay, I can help you out to do the code and anything in between. This will help us. So you can see that this is our next sessions, lexicon techniques. So tokenization, normalization, which is a part of these all. So I will explain that step by step, and then after we will do the syntactic processing. right? Then after next session is semantic processing, pragmatic processing, right? Obviously, we have covered these all because this is a fundamental part of the large language models, right? And then after this is the advanced applications. Okay, so I will try to catch any expert who will maybe become a part of our session. But yeah, right now we are planning to take the next session on lexical processes, syntax, semantic, and pragmatic. Okay, so you can open the second notebook by clicking over here and just go on the open in the code. Okay, and you will see notebook like this. Okay, so I will close this notebook, leave it, and I will connect this one GPU, right? For this notebook, we require GPU. Okay, so I already make up a code for that, so it will directly connect automatically. So now here we have an ngram, right? So this is a topic. So in this notebook, this is our topic. Okay, so over here we are exploring this ngram concept. Then after second concept is like what is a RNN, what is a LSTM, and what is the GRU. So LSTM and GRU. Once I will explain you the RNN. So because obviously that was covered in the theory, you can just go there and see the lecture again to just explore the fundamentals of this code. Okay. So over here, I will explain you basically the core part, right? Core part of this concept. So here, basically, this is known as a language modeling. So first of all, what is language modeling? So language modeling is basically the most important task in NLP that involve predicting the probability distribution for a sequence of word in given the language. So let's say what will be the next one. So when we are doing a Google, right? So let's say I will write state statistics. Okay, you can see that it will predicting the next word, which is known as a sequence of the word, right? So language modeling involve predicting the probability distribution of a sequence of words. So you can see that when I wrote statistic, it is predicting the sequence of class 12 GSCB solutions, or let's say in a Python, in a, let's say COVID-19, let's say I will take this. Then after you can see that when word is entered, it is changed the next word probability, right? Which is totally different one. So it is form the foundation of various applications, right? So these basically the language model is basically the foundation of the various applications. Let's say it is used in the machine translation, speech recognition, text generation, right? So we will explore different approaches to the language modeling, including ngram, RNN, LSTM, and GRU. So let's not talk much. I'm going into the ngram concept. So on the screen, you are able to see that like ngram, which is like a detective in the land of the language, right? So in simple term, let me tell you the definition in simple terms. So let's say ngram is a contiguous sentences, right? Contiguous sentences of n items, or you can say that words, items, instead of item, you can say that words or the characters, right? In a given text or the speech. So how it works? Right. For language modeling is like say for any LLM model. Ngram capture the probability of occurrence of the word based on the context of the previous n minus one words. Right. So here you can see that we have breakdown. Right here you can see that we have break down the words. So they break down the text into the sequence of n words. Right. Study. So here you can see that studying the sentence which is follow the sequence of each other to make educated guesses about the future words, and which I already showcased you in the example of the Google, right? So how it working? So ngram capture the probability, right, of occurrence of the word based on the context of previous n minus words, right? So let's take a unigram. Here you can see that n is equal to 1. 1 means uni, 2 means by, third means try, right? So this way you have to just take this word. So uni means 1. So here n is equal to 1. This is a sentence. So you can see that we are breaking down each individual word separately. This is a sentence. When I tell you, let's say bigram, so we are just pairing the word. These is become the 1. So by means 2. We are breaking the whole sentences into two words. These is, then is a. and a sentence. So this is breakdown, right? And let's say trigram. So we are defining these is a as a 1 gram, right? And then second is a sentence something. So we are defining that three, right? N is equal to n is a particular basically stand for the number of words in a sequence, right? So let's say bigram is a 2. Focus on the pair of the word like these. Focus on the pair of the word these is a sentence something like that, right? And here when I call a frequency is basically the n-gram model. Count how often this sequence appeared in the given text corpus. Text corpus means nothing but the data set which you are able to see on screen, right? So this is basically telling the occurrence of the word pair or the triplets like a meticulous accountant. So it is constantly focusing on the particular number of word occurrence, right? And the last basically its basic is known as a prediction. It will give the prediction of a particular specific sequence. So if you see that I say that any word, let's say I love, their prediction might be the pizza based on the previous observations the trigram have, right? Basis on that, this will happen. So you can see that this is an example. Count the probability of next word for a, right? So this is the house, right? It has predicted. So you can see that it is predicting the joint probability 0.25. Might be that is a house, might be that is a male, might be that is a rat, or might be that is a cat. So this is given the strength of this. So what is the pros and cons? Pros and cons you can read by yourself. This is very easy, but quickly I will tell you. Simple and computationally efficient, which is one like pros. Second is provide the basic understanding. It provides the basic understanding for the local context. Okay, and cons is limited capture of the long sequence of the dependency. So let's say you have your sentence is basically around 500 word long, or let's say one para. Obviously, so this is capture the limited context, and it become hard for computationally, right? So it doesn't handle the unseen combination well, right? So this way, but how we can calculate this? Okay, so for this purpose we are using analytical library. Last time I have showcased you. If you haven't seen that, just go to that video, that is on the session 1. You can go on the analytica ngram, right? So here we have one object analytica ngram. So let me do the Google and showcase you that it's coming. Official website. This is the official website of Analytica. You can see that Analytica model, right? So over there we have you can see that bigram. When you just directly give any sentence to there, it is defined in the bigram. Right. Right, you can see that there are a lot of words regarding the engram. But I will showcase you the simple example that we have calculated. So first of all, here we have used one counter. Counter is for like how many time particular word is repeated. Okay, for that purpose. I will showcase you the code as well. And a random. Random is basically create any random word from particular word index. Okay. So first step is to define the tags. Okay. So here this is our sentence. Language modeling with the ngram is a simple yet effective approach. Step 1 is to always split whole sentence. Okay. So this is known as a tokenizer, and it will give the list of words. So how it look like? Print words. So let me do the comment. I don't need anyway. You can see that this is known as a words, right? Now let's say I want to split this word into the bigram. Okay, ultimately we are giving the value, right? So let's say we want to define the n-gram, but n-gram, let's say for n is equal to 2 I want to define. Okay, so here first of all we are defining the value of n, which is something the size of n-gram, and then after we are using this function n-gram over there. Okay, so first of all what you can do is you are just passing the words and n value, so it will split this word into the two of pieces. by passing inside this function, and then after we're converting this output into the list format directly. Okay, and then output would be look like and grams list, and you can see that it will be look like this, right? Language modeling with and gram is simple, right? This way it will print. Now let me convert into the count vectorizer. So this counter will calculate how many time n-gram list particular word is particular two bigram is repeating. Okay, so this will count, and then after what we are doing is we are converting these into the showcase. So let me showcase you the final output how it will look like. So it will take any random numbers, right, from any random count from this, and then after it will calculate your max value. Max value is basically, here you can see that in the step 4, right? We have used a random choice n-gram list. So when I told you the random list n-gram, this is basically count the occurrence of n-gram using the counter class, right? So counter class is basically, let's say here, so let's say inside the random dot choice, okay, it is randomly choose n-gram from the generated list from input n-gram, right? Generated is input n-gram, and then after it will predict the next word by selecting the n-gram with highest count that matches the last n minus 1 words, right, of the particular input which is provided into the form of n-gram. Okay, and in this last two steps, what it will done is it will print the generated n-gram list, right, which we have generated, and then after it will print the predicted next word. So what would be the next word? So it is predicting the next word is yet. So after this approach, which is a yet, minus 1 means last word. So this way we are creating the n-gram. So here we have taken the example of bigram. Okay, you can also print like this. It is probably predict the probability and printed. Okay. So with the help of Spacey, I have created n-gram is equal to 3, 4. You can do the practice by your own self. Notebook is already provided. Okay, that is the first one. Now, recurrent neural network. Right. So in the figure, you can see that you can explore one cheat sheet which is very famous by the Stanford University, which they have provided. But I also want to tell you that this code, right? Basically, you are able to see that this code, this code. So this is a one new library which is known as a TensorFlow and Keras. I will showcase you that as well. So here we have used a IMDb dataset. I will also give you the explanation of that dataset as well. And then after this is the RNN model, sequential model embedding, simple RNN we have used. And then after this model, neural network, right, which is look like this. This is a training process, which is you can see that like where we are just training the model like this. And then after we are printing the plot. So plot will be look like this. And this is a evaluate the results, and then after at the end we are able to see that it will give the probability with probability value positive or negative sentiments. So this code is basically regarding to the LLM, no, sorry, not LLM, RLM, right? So first of all, for that purpose I will tell you about the TensorFlow. Okay. Okay, so let's go on the first of all on TensorFlow website or Keras website. So you can see that when we are talking about the RNN, CNN, LSTM, right? So basically, it is come as a part of the deep learning. So first part of the deep learning is basically known as sequence to sequence modeling. Right. So maybe you got a friendliness with the, let's say, end-to-end course, where you can see that end-to-end defines this whole deep learning into the three part. One is basically the sequence to sequence learning. Sequence to sequence learning is include time series analytics, as well as it is include the natural language processing task, right? NLP. And then after it is defined the second level, which is known as a CNN. CNN is basically the convolution neural network. So convolution neural network is basically the part of we can say that like convolution neural network is a part of the image based task. So let's say when you have a data in the 3D format, let's say image, video, right, high dimensional data. So that's why high dimensional data. So 3D data is known as a tensor, right? So when you just do the scalar, vector, matrix and tensor, when you do the Google like this, it will showcase you this kind of image. So this is a form of mathematical vectors, which is look like this. So when you have a single value in the particular Excel cell, right, which is known as a scalar. When you have a column, one column, that is also known as a vector. Let's say you have one horizontal row, that is also known as a vector. Let's say you have a whole Excel sheet, that is known as a matrix, 2D matrix. Let's say you have a 3D, three-way tensor, right? So your image is basically known as a three-way, right? So that's why it is known as a tensor, right? So you can also see that image representation, right? Image three channel. Not image three channel, RGB. So you can see that this is known as a 3D, which I already showcased, right? 3D matrix. Red channel, green channel, and blue channel. You can see that there are multiple red, green, and blue. So that's why. So red is one matrix, G is second matrix, and B is the third matrix. So it is ultimately converted into the 3D, right? This way, right? So this is known as a channel. Every matrix is considered as a channel 0, channel 1, channel 2. These is become the 3D matrix. So that's why when your data is 3D, so its computation is become so complex. So that's why it is known as a tensor algebra. Maybe have you ever explored tensor algebra? So when you see the tensor algebra, it will showcase you like this. You can see that this is a mathematics, huh, guys. Tensor algebra is basically the 3D calculation mathematics. You can explore. So inside image and all, we are using a multiplication, but that multiplication is basically known as a matrix multiplication. And the CNN or whatever the neural network is, this is a basic operation which is used in the any neural network. Okay, so let me come on the RNN. Right. So in previous lectures, you have seen that recurrent neural network, which are the part of the neural network architecture design for sequential data processing. So sequential data processing is something like, let's say you have a grammatical sentence, which is where the sequences matter. Let's say in time series, where the sequences matter. Right. So unlike traditional feed forward neural network, RNN have the connection that form the directed cycles, allowing them to maintain the hidden state that capture the information about the previous input, right? You can see that's the same thing on this image, right? Like RNNs, which is allowing to maintain the hidden state that capture the information about the previous state. So let's say over here, this is maintain the information about the previous state. Over here, it is maintain the previous state, right? A t minus 1, right? So these characteristics make RNN particularly suitable for the task solving the sequence. So it is used in time series task, it is used in speech recognition, it is used in NLP, right? So what is the key concept in RNN? So first key concept is a sequential processing, right? So traditional network. So let's say normal neural network has a limitations. So the standard neural network process input data independently, but without considering the backward sequence, right? It will not take a previous input, right? So that's why here we need actually considering the sequence nature of the information. Second is a need for why need for the sequential model, because sequential data like sequence of the time series often exhibit dependency where the context of the one element influence the understanding of the next sentence, right? So there are inside the architecture, like whenever you see the RNN architecture like this, right? You always see that RNN introduce a recurrent connection. Recurrent means like it's repeating itself, right? So that is known as a recurrent connections. So recurrent connections that allow the information to be passed from one step to the sequence to the next. So it will predicting for you only the one word, right? So you can see that same thing, right? Recurrent network, right? And also inside this architecture we are using a hidden state. So these hidden state maintain and like it will maintain the hidden state inside this neural network that serve as a memory. Memory is something like it is stored that previous word, right? Which is capturing the information about the sequence seen so far, right? Okay, now inside this, there is a basically the forward propagation and backward propagation. Forward propagation is a simply known as each time step. So let's say here one, two, these are the known as a time step, right? You are able to one, two, t plus one. So these are known as a time step. At time one, at time two, up to at time t plus one. That way you can consider. So at each time step, the network take an input and the hidden state from the previous step. So whenever you are taking a t plus one, right, your hidden state become the at, right, or ht. Ht is your previous information. So only the one previous information is stored, right? And there is a other rule known as a update rule in forward propagation. That is known as the hidden state is updated based on the current input and the information carried from the previous step. So this is a two part of the forward propagation, input and hidden state, where each timestamp of the network take an input and the hidden state from the previous step. And update rule is like it is taking the hidden state is updated basis on the current input and the information carried from the previous step. So this is basically the architectural things of like a forward propagation. But there is a one disadvantage of back propagation. Sorry, no, for RNN. Right, RNN. So when you are training the RNN, invoke the back propagation through time. Okay. So there are two challenges. First is the training challenges. So when we are training RNN, which involve the back propagation through time, which extend the standard back propagation algorithm to sequential data, right? And it is raising the two type of the problem: vanishing gradient and exploding gradient problem. So now everyone have the question, right? What is vanishing gradient and what is exploding gradient? So let me tell you in a simple language. So vanishing gradient problem is basically, you can say that like when you are training any neural network, okay, let's say you are training any neural network, especially for those which have a many layers, so multiple layers, okay, and the gradient means slope, right? So let me showcase you over here, right? So this is known as a slope, right? So inside these, when training so let's say you are training any neural network, okay, and which is contain a lot of layers, right? And this gradient means nothing but the slope of the loss function. So here you can see that this is a loss function. So here we are getting the slope, right? So slope of the loss function with respect to the model parameter, right? So model parameter is nothing but can become extremely small as they are backpropagated through network, right? So this is a big issue, right? Loss function with respect to the model parameter that can become extremely small as they backpropagate through the layers, right? So we are getting the not particular. So what consequences happen when this kind of issues happen? So the small gradient leads to very tiny update to the model weights during the training, right? So tiny weights means as a result, early layer of the network learn very slowly or almost not at all, right? So your neural network, so ultimately what we called it, so in simple term we can say that it is like trying to climb a gentle slope where each step you take is so small, take you make a little progress, right? So it is taking like your model is learning very slowly, it is showcasing that. So that is known as a vanishing gradient problem. An exploding gradient is like, So what issue happen when exploding gradient is exploding gradient occur when when we can say that become extensively large during the backpropagation. So it will taking a jump very faster. Right. So same way you can imagine like climbing a slope where each step is so huge. Right. So directly, let's say you are taking a helicopter and you're climbing. You are just directly taking a land there. So that you end up far away from the intended part. Right. So whatever the path you have to take, you are not taking it directly, you jump on the particular point. That is known as exploding gradient. So what consequences happen? So let's say large gradient cause a dramatic update in the model weights, which is leading the unstable prediction results. It may cause the model to overshoot the optimal solution and fail to converge when it's really needed. So these issues are especially pronounced in deep learning with many layers and can hinder the model ability to learn effectively. Right. So technically, I can say that like a careful weight initialization we have to define using active function that mitigate this vanishing gradient problem. So these are the something technique which we are try to prevent this kind of right. Okay, so let's not go into that much of detail because there are also the type of RNN which is many to one, one to many, many to many, right? So let me give you these very brief. So many to one. Okay. So many to one basically used a task where entire sequence is processed to produce a single output. So let's say you have a sentence, okay, you are putting that into the neural network and you want only the output is let's say positive sentiment, negative sentiment. So many to one. So your sentence is contains many examples. And from that you want to classify something. So that is known as sentiment classification. So that is known as many to one. But let's say one to many. So when you are applying a single input, it generates the multiple output. Let's say you are providing one image and it is generating the description for your image. That is known as one to many example. Right. Now many to many. So let's say you are using a Google Translator. You are giving a let's say English sentence and you want to convert into the Hindi sentence. So that is known as many input you have given and many output you are getting. So that is a simple types of the RNN. Right. So let's directly dive into, but before that, this is the official library that we are using, right? So it is the part of the TensorFlow, PyTorch, and the JAX, right? And this is the 3.0 is latestly recently launched. So this is the API. So by using this library, we are creating the neural net. Okay, these are the multiple, multiple layer, multiple kind of the different kind of the function model APIs, layer APIs. So when you want to create a layer, right, you have to just go through these kind of the different type of the layers. So I will showcase you step by step, like on which time, which layer during the RNN we are using. Okay, so let's directly dive into the RNN. So here you can see the TensorFlow. So let me showcase you the TensorFlow. So Keras is a subpart of the TensorFlow. Okay, Keras is a subpart of the TensorFlow. Now it's a subpart of the PyTorch and it's also the subpart of the JAX as well. So with the help of these three packages, you can use. Right. So learn. When you want to learn TensorFlow, you can just directly go on learn section. You will get it. Okay. So TensorFlow is official platform designed by Google. Okay, this is a Google framework, which is very famous. So over here, you can see that TensorFlow we are using during to explaining this one, right? So here, when we want to define the any neural network, we are using this TensorFlow library, which is basically known as a deep learning library, right? So you can go through the some its basic beginner courses tutorial, and you will easily understand like okay why we are using a TensorFlow. As I already told you, right? We have let's say when our matrix size and high dimensional data is increasing, we are using deep learning. And deep learning is basically help us to solve this high dimensional data. Okay, and here we are using IMDb dataset, which is a movie review dataset, right? Right, this is a movie review dataset. So where we are just taking a multiple movie dataset, and I will showcase you each and every step. Okay. So first of all, we are defining the TensorFlow, which is imported. Okay, and from the TensorFlow, we are using IMDb dataset, which is a movie review dataset. And from inside that, we are using paid sequence. Paid sequence is nothing when your data. Let's say you have multiple sentence, but every sentence contains a different length. Okay, that time Where there is a no word, you have to just repeat with zero. That is known as a padding. Sequence is nothing but one layer where we are just putting inside all. Sequence is one modeling, right? As I told you, sequential modeling. So we are taking that sequence and we are just setting step by step all the layer inside the sequence model. Okay, and then after we were printing the plot and everything, which is look like. So for that running purpose, I will run this TensorFlow. So these line import the necessary libraries and modules. So TensorFlow is used for creating and training the neural net, right? And the code specify utilize a module for working with IMDb dataset. Okay, and then after we will do pre-processing and building the sequential neural network model, and also at the end we will visualize the training history. Okay, now inside this tab, or I can say this section sets the number of parameter, right? IMDb parameter. So it specifies the maximum number of words. So 10,000 is the maximum number of words we are taking, right? It is showcasing the maximum length of movie review, which is known as a max length 100, right? Which is cut the text after the number of 100 words. So let's say you have one sentence and we will directly split that into the particular length, right? So whatever it is after come for particular 100 word, that will be cutting down, right? And at the last, IMDb don't load data. So here, like TensorFlow has an inbuilt functionality, which is help us to load the data set directly. So here we are using IMDb dataset, which is so load data is the one function where we are passing the max feature. Max feature is nothing but number of columns. Okay, and it will generate the data set and it is storing the text data. Sorry, into the two part, train data and test data. So for train data and test data, there is a concept. Okay, whenever you are using train and test data. So when you imagine train and test data, so let's say you have 100 rows. Okay, 100. So let's say when you have 100 rows of data set, this is your Excel column. Okay, this is a pool of data set. You have a one column which is known as a Y. Let's say sentiment classification. Here we have a data set, right? So let's say you have a number of column. Okay, and this is a target. So as a feature, just imagine TF-IDF. Okay, TF-IDF. This is a table of TF-IDF, and this is a target column. The target column is nothing but the positive or negative. Okay, this column containing two type of the data. One is a column like one row contain the positive negative sentiment. Okay, and then after what we are doing, this feature and target, we are splitting into the two part, right? Train test. So we are splitting into this training part and this is the testing part. So training part is used for training the deep learning model, and testing part we are using for validating the performance of the deep learning our RNN model, right? So this way we are just splitting the data set. Okay, from Excel sheet to features to target to train and test, and then after train part we will give to the model and test part it will give to the directly for the testing of this model. So here I will load this data set. So you can see that it is downloaded from the internet and automatically loaded for us. And then after, let me just, you can see that it is come up with these numbers. And dot, let's see how many type of these values we are containing. You can see that there are multiple functions, right? When we are just printing data, what we are getting, memory view. Okay, so it is showcasing the memory, right? So values, do we get the values? Yeah, you can see that there are multiple functions. You can check the dimension as well, right? It's a one dimensional data. So this is a basically this is a data set. If you want to see, you can explore the TensorFlow or the these library, right? But if you want to see, let me suppose IMDb, right? This is a real data set. You are able to see over here. Okay, you can load by doing this. Large movie value data set, right? Oh, it is containing 80 MB. But let me see if we can see it over here. Um, okay, you can see that I am DB movie reviews. Okay, so there are multiple data set. This way you can take it, right? You can see that movie IMDb for the subwords of 8K. There are multiple. So here we are loading the default one. Okay, we are loading the default one, which will help us to see that like okay, what is the default value of that particular data. Even we can explore the data set over here. There are a lot of paper written on it, right? You can see there are a lot of paper written on it. Now what we can do is we are just giving the paid sequence. So paid sequence is basically where the length is not fitted particular, right? So that time we are just truncate that and we will cut that text after the 100 words. So in the paid sequence, whenever here we are using training data or testing data, we are converting into the 100 max length 100 and we are just running this. Okay, so it will showcasing the processed data. So this paid sequence basically known as a function which is applied to ensure that all the sequence movie review have the same length and it paid the shorter, right? Okay, so now this is the time to create model. Okay, so basically, so this part is basically the RNN. So as I already told you, right, sequence is basically the model, and one by one we are adding the layer inside that, right? So first layer is known as embedding layer. So embedding layer is where you are just passing your max features, which is let's say 10,000, right? So here we are passing the max features. So these become our 10,000 rows and 32 columns. These way become embedding vector. So what is embedding vector? So when we are passing and when we are just creating the image, you can I will suggest embedding vector embedding embedding. Okay, yeah. Just a minute. If this looks good, and I will suppose. Yeah, you can see that embedding will be like this. So these will create the embedding matrix. Okay. So let's say you have X value and Y value, right? X value is something that converted what into the particular count vectorizer, whatever. And then after first step is it will convert into the embedding vector. Right. So embedding vector is basically you are able to see that it is a consist of embedding layer, which is nothing but create the one matrix, which is this vector, which is basically used to just train the our large sorry our RNN model, right? So inside the RNN model, inside the RNN model, what we are doing is we are taking these vector as embedding vector, right? So all the size is a fixed there. So basically, when we are using embedding layer, do you know anyone? Because embedding layer is very important. Right. So embedding layer is used in neural network, particularly in the nature, basically when our task is basically regarding to the NLP. So when we are dealing with the categorical data, such as let's say word or the tokens, it is the primary purpose, right? To convert this categorical input into the dense vector. So you are able to see that we have a dense vector over here, right? So this dense vector, which can help us to learn during the training process. So here you can see that we have, you can see that this is converted embedding vector, right? So basically this is something like sparse matrix kind of things. So when you are working with high dimensional data, sparse input data, let's say so sparse matrix is something like which is contain more zero values, right? And embedding layer can efficiently map the sparse input to the dense vector. And this dense representation is generally more, we can say that more manageable and allow the neural network to run meaningful pattern, right? So you are able to see that the same thing, right? These basically these embedding layer convert these into the need of updated together values. So where we are just giving the embedding longer input and it will give the output say something like 1 cross 4 cross 2, right? And then after we will convert these into the flat. So when we convert into flat means 1 cross 4 cross 2, so it's giving us 1 cross 8. So it will convert into the dense vector. Dense is something like flatten vector, right? You can see that flatten layer. So we are converting this into a flatten, and then after we will apply the activation function there, which is nothing but the output cell. So I will also explain that as well. So same way we are creating the neural network. You can see that first of all we are giving the embedding layer, then after 32 simple RNN layer. So RNN layer is nothing but it will just create the 32 right, 32 RNN layer, RNN hidden layers, right? And that hidden layers is basically stored the that hidden layer stored one its previous value, right? One its previous value means one. So simple RNN 32 units. So this is known as a units basically. So it is stored the like basically 32 hidden layer, right? And then after we are using a dense layer, right? So dense layer with sigmoid activation function. So dense layer with sigmoid activation function. There are types of activation functions. When you type like types of active. So why we are using activation function? So in mathematics, there are a lot of values which is come with the different min max range, right? So when you want to just transform that min max range value into a particular range, that time you are using activation functions. So these activation functions contain the linear activation function or non-linear activation function. So in neural network, we are using mostly the non-linear activation functions. Maybe you have seen this kind of the images on internet where the person you can see something like that, right? Cow. This is clear or not? Let me check. No, this is not that much clear. Let me take another one. Yeah, this one is looks okay. So let's say we are taking one value, okay, and you want to convert that value into the 0 to 1. That time, which activation function you are using between 0 to 1? You can see that between 0 to 1 you want to convert, right? So that time we are using sigmoid activation. So 0 to 1, 0 means and 1 means, so 0 means there is a positive sentiment and 1 means there is a negative sentiment. Just imagine on that way. So that time we are using sigmoid function. So you can even also map these with the probability. It will also give the probability value, right? And you can convert it into the 0 or 1 basis on the range, right? Even we can use 10, right, which is known as hyperbolic 10, where you want to convert your value with -1 to 1, right? Same way we are using a step function, linear function value is something like this. ReLU function value is something like, let's say you have a negative value, right, which is a less than 0. It will convert that into the flat line of negative y, sorry, negative x. But let's say you have a positive value, then it will not doing anything and it will stored as it is, right? So these is nothing but the number of activation values, right? So that's why here we are using sigmoid, because we have a output is like only two category, positive sentiment or negative sentiment, right? So that's why we are using 0 and 1. But let's say you have multiple categories, so that time we are using a soft max activation, which is basically support the multiple category, which will help us to predict the category for multiple category, right? So this way we are creating the neural network, and after creating this neural network we have to compile that. So model compilation with Adam optimizer. So this is doing the back propagation. Okay, as I already told you, when this neural network do the mistake, this optimizer help to solve that mistake and try to learn again, right? So how many times this model will learn? So whatever number of value you can give to just learn it, it will learn it. Okay, and here we are using a binary cross entropy. Binary cross entropy is nothing but giving a calculate the value of loss function. Obviously, whatever we will learn, let's say we are trying to learn first time. So we are only remember 50%. 50% we are not understanding. Okay. So that 50% we are not understanding, that is known as our loss. Right. So that way it is also calculating its own loss and try to improve themselves by using optimizer, like which way I can learn so it will improve its performance that way. Okay. And accuracy we are measuring. Okay, so by learning, let's say you remember 50%, so that is your accuracy. So that way we are learn the accuracy. This way we are building the neural network, and summary will display like, okay, this is your input. Okay, 32 multiply 10,000, so it will calculate the parameter. And on the next step it will also calculate like 32 multiply whatever the next step is come, and these ultimately become the model size, 1.23 MB of model size. Now this is the time to feed the model, like how many time it will learn. So let's say we want to teach the model 5 times. Okay, so when you are putting this, it will train itself a 5 times and it will start training. Guys, this will take a lot of time of training. Okay, so I will not train whole the network and all, but this will take a lot of time. You can see that. You can see that it will take a lot of time. So just imagine chat gpt, it has around 600 GB or 1 TB of data which they have used to train their model. So when you do the Google, how much time taken by chat gpt to train, you can see that how many days, 34 days they have taken, and they have used 1023 GPUs, which is a very big infrastructure recommend, like provided by Microsoft. So its cost is around $10 million. Okay, so this is approx number, but yeah, maybe it will be higher or lesser. So this is a GPU, you can see T4. Here we are using a T4 GPU. So we have only one GPU right now, and this kind of the normal task will only take a one GPU. Okay, so you can see that at the first time their loss is 50% and accuracy is 73%. Right, this is a training accuracy and training loss, right, on training data, and this is on testing data, right, that I already showcased you, trained and test, right, this one. Right, so first accuracy is for the training data and second accuracy for the test data, so you are able to see on that way. Okay, so once this will be trained, we are just creating the plot for the same. So plot you can learn step by step. Okay, once you will go for that library, and it will display like this, something like this. I'm not telling exactly, it will display every time. It will be changed if you are not defined some seeds. Seeds is nothing but same time. Every time it will split X train Y train rows same. Let's say first 100 you have 100 rows, right? So first 80 rows goes for the training and 20 rows go for the testing. So that way you can just train your and test seeds you have to define. So when let's say you are defining 42, so every time it will split index same, okay, for the training purpose and testing purpose. And after end of the day you will get something output like this. So once your model is trained for the 5 epoch, you can see that we have a 4 epoch, right? So 0 to 4 is an index. So 0 is a 1, 1 is a 2, 2 is a 3, 3 is a 4, 4 is a 5, that way. So here you can see that model is learning. So this is the training curve. So by seeing this plot, you can see that like by the time when epoch is increased, model training accuracy is increased. Okay, but when it's take a testing data as the input, it accuracy is decreasing after taking 83. So these so which is the best model, obviously. So basis on that we can define which is converge well, which is known as a best model. Okay, so also you are able to see that model loss. Okay, so inside the model loss you can see that like just a minute. So inside the model loss, you can see that our training loss is constantly increasing, right? Sorry, validation loss is constantly increasing, right, which is a orange line, and training loss is decreasing. Okay, right, training loss is decreasing. So basis on the image, you can just interpret how neural network is performing, right? So this neural network is telling you that like what is the performance of the model, right? So we have a two type of the things, right? Training accuracy, training loss, validation accuracy, validation loss. So in training accuracy, like cow shows how the model performance is changing over the time as it is being trained, right? So in the ideal case, training accuracy will increase and the training loss will be decreased as the model learns from the training data. But when we call validation accuracy and validation loss curve, shows that how the model is performing on the separated set of the data that is not used for the training. So this is important because it helps to prevent the model from overfitting to training the data. So overfitting occur when the model learns the training data too well, and it is not to generalize to the new data for the test data. So in this graph, right, in this graph that shows that like training accuracy increasing, training loss is decreasing over the time. So this suggests that model is learning from the training data. However, the validation accuracy is not increasing as quickly as the training accuracy, right? So these could be the sign of overfitting to the training data. So the best loss is lowest value of the validation loss that is achieved during the training. The best accuracy is highest value of the validation accuracy that is achieved during the training, right? So the epoch, and also what is the epoch? So epoch is a unit of measurement that refer to the one pass through entire training data set, right? And this graph shows that the model has been trained for the 4 epoch, right? So basis on that, we can just we are just learning that how training data is performing, right? So this model is overfitting, okay? And now we will check that taste loss and taste accuracy, right? So what is the best taste loss and taste accuracy? So it is giving us. So this is a nothing but known as an evaluation of model, which is giving us the accuracy and the loss. So now I'm not doing any further training because it is taking a lot of time. So when you are applying for the test data, right? Whenever you are applying for the test data, like IMDb data set, this so here we have created one pre-processing. Pre-processing nothing but we have applied padding over here, nothing more than that. So padding, and then after padding, like we have saved based model, right? Here we have saved based model. Okay. So this based model will load again and so when you want to, let's say, put this model into the production, that time you have to create the script like this, which is known as inference script, right? Which is known as a inference script, and you have to apply these inference script there, right? This code is repeating from first function to prepare the new data. Here we are loading the based model, right? Based model is nothing but when we trained a 5 epoch, okay, from that 5 epoch which based epoch we are getting, and basis on that we save that model automatically, right? So that epoch is known as a trained, like we are training the model, okay. And here we are taking one example text, like it will predicting for us is like, okay, this is a positive sentiment or this is a or negative sentiment. So here we are taking the sample text. This movie is amazing and I love every moment of it, which is no which is doing a pre-process over there, over above, and it will so it will give us a prediction of positive or negative basis on the pre-processed input, and prediction is giving us the in form of probability, right? So you can see that when we run it, obviously right now maybe do we have the model or not, I don't know. Yeah, we don't have the model. Okay, so for that purpose we have to save this model. So what I can do is I will define one code here, model dot save. I will save this model. Okay, base model is saved. Now I will run it and it will not giving the error now. Okay, it is predicting, right? You can see that it is a negative sentiment. But here our model is giving a overfitting, so that's why it is not giving a good result, right? Okay, so model is predict. So this is an example of many to one, right? Many to one. Many to one is, you can see that many to one sentiment classification, right? Where you are giving the multiple like multiple words to the model, and it will give you the classification is like positive or negative sentiments. Okay, so our session is over here. And next, so for further practices, same way LSTM and GRU you can perform. So I have already provided the code for LSTM for the same example. You can run it over here, LSTM. Okay, same code I have provided, and it will plot and everything. Okay, but you can do the same code for GRU. Okay, and that is in your self study. GRU link I have provided over here, so you can do practice by your own self. Okay, and even its animation is giving over here, so you can understand which step by step mathematical operations it will done. Okay, so this is basically the like this is basically the hands-on session today I have covered. So guys, thank you so much. If you have any question, you can ask, and if you don't have any questions, that is. If you don't have any question, then I think we can wrap up the session. So if you have any questions, guys, you can ask. Okay, I think no one have any questions. Okay, so what we can do is we can wrap up this session, and next time, whenever on next Saturday. So guys, every Saturday session will be there. Okay, so when this NLP session will be over, so we are trying to also collaborate with some of the organization where we are providing the certificate to you, right? And at the end of the this course, we are also trying to create one hackathon, right? So that is still in the pipeline. We are trying to just connect with the different companies to just make them organize with the help of them. And so we are trying now. So once it will be finalized, we will inform you via the mail. And and these for these sessions, yeah, this kind of a session will be coming back to back. Okay, so maybe more two sessions, and these NLP crash course will be end. But hope you like it, and if you like it, just share with others who want to learn this LLM engineering course. Okay, thank you so much for your today's presence. Thank you.